Hello everyone, here I am again, biology video this time. Hopefully you managed all the work that I set on populations for you the other day, and we're now ready to move on. I'm going to make a video covering the carbon cycle and the greenhouse effect for you today. Right, actually before I move on to talk about the carbon cycle, just a quick word about one of the tasks I set you the other day, which I realised in hindsight I should have possibly explained a bit more, especially for those who are non-mathematicians. Anyway, sheet 1.5.11 has this table at the beginning showing the log of the number of bacteria rather than the actual number of bacteria. Right, what is this log business and why is it in that table? Why don't we just put the actual number? What is a log for starters? Well, I'll show you how to see what the real number of bacteria would have been. Hopefully many of you got a calculator the same or similar to this one. If you press Shift log, you'll get that appear on the screen. And press, my keys are a bit battered and worn out. I'm such a keen mathematician, I've worn out my calculator. So you put that in and you'll get that number, basically 15,849. That's the actual number of bacteria that there were at the start. Right, if I do the same just with the final row of the table, I've already put in the shift log 7.2. Let's just press the equals, and that's what I get. Look at that. That's a massive number, 15 million, in fact 848,931. In fact 932 rounds to the nearest whole number. So let's just write in those two numbers only. Now imagine plotting a graph with those real numbers on. It would be impossible to have a scale which would allow you on the same scale to fairly precisely plot 15,000 and 15 million on the same scale. So we often work out logs of numbers really to make them more manageable. These are huge numbers, as you can see. They don't only make the numbers more manageable. Focus playing up for some reason. As I was saying, they don't only make the numbers more manageable, it makes them plottable on a graph. There was no way you could plot these actual numbers on the same graph. So that's why we often use logs. Right, and with that bit of help, you could now go ahead and answer B and C. Obviously, you'll have to read off your graph to work out what the logs are for C, but you now know how to convert logs into an actual number. Some questions get you to do it the other way around. Questions like this, just don't press Shift, just press log of the relevant number. So I've just typed that into my calculator, and there's your answer, 7.5 basically. Right, that's enough on that. Let's get down to the main business of today's session. Continuing topic 1.5. Sent you this checklist the other day. You've covered the first four learning aims, which I've highlighted there by doing the notes and questions I set you on Tuesday. We're not going to do this bit on sampling for the time being, so this is best covered through doing actual practical work. So I think we're just going to leave that at least for the now. And we're going to move on to these parts here on the carbon cycle for today. Right, I've sent you an attachment with a little exercise on the carbon cycle, which you can sort of cut out and stick into that part of your notes on page 2. And here's the attachment that I sent you. As I've said, cut out those 5 boxes, arrange them in the pattern shown. I'll let you decide which box is best put in which position logically. You've then got to draw 10 arrows. Not every box is linked to every single box. You decide where the 10 arrows go and label them with each of those terms. I will provide you with a little bit of help. I suspect many of you could probably do this, or at least do almost all of it, without me even giving you any help. But I'll give a quick bit of guidance or background teaching on this anyway. Right, I've also sent you this PowerPoint, and it's worth saying straight away that actually carbon itself, the element carbon, is not what is cycled between living organisms and the environment. It is carbon containing compounds, largely those. In living organisms, you generally find these three types of compound, which, as you well know by now, contain a large portion of carbon within them. Outside of living organisms, you chiefly get carbon dioxide in the atmosphere, fossil fuels in the ground. Now, here's a typical diagram showing the carbon cycle for you. Most of it is pretty straightforward. Of course, plants generally make carbohydrates. Some plants get eaten by animals. That carbon passes into them. And those plants which don't get eaten by animals, and the animals themselves, will die at some point. Now, in nearly all cases, 99.9% of cases, when an animal or a plant dies, they decompose aerobically. Their bodies are basically fed on by decomposers, largely bacteria, but fungi as well. And those bacteria and fungi ultimately basically use the carbohydrates or other organisms in those dead organisms for their own respiration. And a lot of this carbon is simply returned to the atmosphere. So carbon dioxide taken in by plants goes to animals. Both of these die and decay, and the carbon dioxide via decomposers goes back to the atmosphere. Now, there is just one extra fate which can, on very rare occasions, befall plants or animals when they die. And that is, they don't decay normally under aerobic conditions. They decay anaerobically, which means they don't decay in the normal way. Basically, this happens when they either fall to the bottom of deep oceans, get covered up by sand and silt, and this means it's anaerobic conditions. Their bodies will not be fed on by decomposers. Same thing can happen in swamps at times with very muddy bottoms to them. No oxygen can get to the remains, and they don't decompose in the normal way. What happens basically is that they decompose very slowly and anaerobically, and only really partly decompose, and heat and pressure act on them as well and convert them into fossil fuels. Okay, pause my video at this point please and complete that carbon cycle exercise. You know, this is done stuck onto your note sheet. When you're done with that, come back to me. Right, we've now got to go on to talk about carbon footprints, global warming and the greenhouse effect. Starters, that definition of a carbon footprint has to be recalled. That's all you need to know for the exam, but wait a minute, we're not just leaving such a crucial matter as getting you to remember one definition and then moving on. Well, this is serious stuff. This affects the real world. Let's have a closer look at carbon footprints. Right, start with a quick little challenge for your 7 countries there. Could you place those 7 countries in order of the average carbon footprint of people living in that country. This is the average carbon footprint per person of people living in those countries, highest to lowest. And if you're thinking, I don't even know where some of those countries are, how am I supposed to do this? Well, shame on you. Get an atlas out and look up where they are and have a go anyway. Right, easy to begin with, isn't it? Those awful gas guzzling Americans got to be number one, haven't they? Or have they? Actually, the USA is only number 2, let me tell you. Which do you think is number 1? Is it us? Are we really that bad? No, it's not us either. It's those damn people from down under, those Australians. Got a little table to show you here, actually. Emissions per capita, which basically just means carbon footprint per person. Got Australia there, just ahead of the United States. We're a lot lower. We need not feel too ashamed of ourselves. Well, it depends who you're comparing us to, of course. Compared to those two countries, we can sit here feeling pretty smug, can't we? But notice, oh, don't know what happened there. Sorry, I must have nudged the mouse. Anyway, look, most of Europe is a lot lower than the US and Australia. Germany on a par with us pretty much. France actually lower than us. Anyway, back to our exercise. The actual answers are there. Obviously the 3 sort of fully developed countries are the top 3. Some people think of China as being awful for belching out loads and loads of air pollution and emissions. Well, they're not necessarily innocent of that at all. But, you know, China is still a long way behind the United States and Europe in terms of overall development of the country. Yes, some people in the big cities in China lead pretty Western lifestyles, and they do burn huge amounts of coal to make power, etc. But there's still a lot of people in China who still basically live peasant-style lifestyles out in the little villages, just farming their own land. Also, though, look at the changes, percentage change. So that's really over the last 24 years, isn't it? Look at China there. It's really coming up. We're one of the few countries going down, you will see from this. Another thing we can be reasonably proud of. But, having said that, we're still number 3 on the list. You can see Brazil right down there at 2.01, and Turkey sort of is a semi-developed country there. Kenya in Africa, 0.3. So when I said we've possibly got reason to be smug, well, it depends who you're comparing us to, don't we? We may only have half the impact Americans do, but compared to your average Kenyan, we emit about 30 times the amount of carbon dioxide as your average Kenyan per year. And you know what that means? Basically, we have 30 times the impact on the planet's resources that the average Kenyan does, 3 times the impact your average Turk, 4.5 times your average Brazilian. Us people in the Western world, whilst these are just sort of carbon dioxide emissions, they're going to be closely proportional to our basically overall impact on the Earth's resources. In the Western world, we do have a really disproportionate effect on depletion of the planet's resources and pollution of the planet as well, of course. So whilst we are improving, let's not be all doom and gloom. We've still got quite a way to go. Yeah, we've all seen graphs like this of carbon dioxide levels shooting up, average global temperatures shooting up, the awful impact it has on coral reefs, polar bears, etc., causes increased droughts in parts of the world, extreme weather, etc. Disproportionate impact on the poorest people, of course. And often what we all do is sit around saying, oh, isn't it terrible? The world is under great threat from this problem, but these awful politicians and these awful big businesses, they don't give a damn about us ordinary people, do they? They just carry on polluting the world. Or do they? Is it politicians polluting the world? No more than your average person anyway. They're just people the same as me and you. They might be slightly richer on average, some of them, and therefore have a slightly bigger impact. They're doing it. Is it just big business and industries who go around causing all this pollution then? Well, let's have a look. Right, where's all the carbon dioxide coming from? Well, about a fifth of it from industry. Larger portions actually, electricity and heat production, agriculture, transportation, not actually larger than industry, but still a significant chunk. So, yeah, industry, get your act together, big industries. But wait a minute, it's not just that, it's these awful electricity producing companies, these awful farmers, and these awful transport companies and oil companies who are causing all the problem, isn't it? They need to get their act together and stop polluting our planet. Well, hang on a minute, let's look at the situation even more. What about all this electricity that's being produced then? Electricity, the biggest contributing factor, electricity and heat anyway. Electricity consumption by sector, actually the biggest sector is residential. People in their own houses who use a large chunk of electricity. What about this 14% transportation? Well, nearly all of that comes from road transport. Aviation only contributes 12.5% of the 14%. That's not 12%. Flying is a factor, and we could all do with reducing the amount that we fly, something that is actually happening at the moment, of course, one of the positives of this current situation. Maritime, this would largely be cargo ships transporting things around the world, but it's basically road transport. We're all contributing to it every time we get in a car and drive, same as we're all contributing to it every time we turn on an electrical appliance or the central heating at home. Also, agriculture, mentioned on there, 24%. Where does all that come from? Well, another pie chart here which breaks it down even more. Of that 24% of agriculture, 14.5% of that 24% basically comes from livestock farming. And out of that 14.5, 9.4% comes from cows. In other words, the beef and dairy industries, with other livestock making up another 5%. So that's basically meat and dairy farming that's contributing a lot to this problem as well. Anyway, as I said, I wish these politicians and these industries would sort this problem out. They just don't care at all. Now, anyway, I'm going to pause this video because I'm going to get in my car and drive down to McDonald's, even though I could walk it in 10 minutes. I'm going to drive down there. Oh, actually, before I go, I must put a shirt in the tumble dryer for 10 minutes and dry it first as well. And as I say, I'm really angry at these politicians for not doing anything about it. Well, hang on a minute. You won't catch me going anywhere near McDonald's. I certainly don't eat junk food like that, and you wouldn't catch me jumping in a car to go 10 minutes down the road either. And personally, I never use a tumble dryer. Now, I don't mean to sound too high and mighty. I'm not perfect, far from it. I contribute far more than your average African to this problem, I don't deny it. But I do try. And the point is, basically, we're all causing this problem. It's not politicians and big businesses who are causing this problem. They could perhaps do more to help solve it, and by all means put pressure on them to do so. But don't then insist that your dad gives you a lift down the road and your mum throws your top in the tumble dryer at the next minute. We've all got to do our bit. to solve this problem is the message. What can you do? As I say, if you really care about the problem and you really care about the future of the planet, polar bears, etc., several things you can do. Don't put your clothes in a tumble dryer. Reduce your heating. I remember reading a while ago that the average thermostat in this country used to be at 17 degrees 30 years ago. Now it's at 21 degrees. People often sit around in a t-shirt in their own house and whack the heating up, put a sweater on and turn it down. Other things about less water in the kettle, less time in the shower, turning electrical equipment on. Those are sort of very simple measures you can take which will save you money as well as saving the planet. Another way of looking at it, if you want to simply reduce your carbon footprint most effectively, as opposed to sort of saving money whilst also reducing your impact to an extent, cut down on your air travel, eat less meat. We saw the pie chart earlier indicating the role of livestock in this. Turn down your home heating, we've already said. Number 4 about changing your boiler won't apply to you now. Number 5 probably does apply to some of you already, and those it doesn't will soon do so. Always think about whether you really need to get in a car and drive. Of course we all do at times. I get in a car and drive at times. But I always try to think, do I really need to drive, or could I find an alternative way of doing this journey? That's all you can do is sort of at least just try to reduce your impact a little. Anyway, enough of all this nagging, preaching, proselytising by me, whatever you want to call it. Sorry if I've gone a little bit. Anyway, you always have the option of skipping past that bit, of course. Now, let's get back to the nitty-gritty of what we need to know. The greenhouse effect and global warming don't mean exactly the same thing for starters. Global warming basically just describes the fact that the Earth is getting warmer. The greenhouse effect does not mean the same as global warming, but the greenhouse effect causes global warming. As shown in this little image, solar radiation hits the Earth. That radiation from the sun warms up the Earth. The Earth then re-emits, because the Earth is then hotter than the space around it. Heat will always travel from hot to cold places. The Earth re-emits some of that heat radiation, or as it's often called, infrared radiation, just another word for heat radiation, back out into space. Some of that heat radiation doesn't escape into space though. It is absorbed by greenhouse gases in the atmosphere, making the atmosphere get warmer. Some of it does escape into space. And the larger the concentration of greenhouse gases in the atmosphere, the more heat is absorbed by the atmosphere and the less heat escapes into space. So, terrible thing, this greenhouse effect, isn't it? No, it's not actually. If there was no greenhouse effect at all, the average temperature on the planet would be well below 0 degrees. In fact, I was just double checking the exact temperature it would be. It's estimated that the Earth's average temperature would be minus 18 without the greenhouse effect. As it is, the average temperature on the planet is 15 degrees. So, contributes 33 degree rise. So it's a good thing. To an extent, of course. The trouble is we're having a little bit too much of a good thing these days. Now, I mentioned greenhouse gases. Just there. What are these greenhouse gases? As we all know, the main greenhouse effect is, or the main greenhouse gas is, of course, carbon dioxide. Or is it? Those in my chemistry class will already know it's not. Water vapour. It contributes 95% of the greenhouse effect is due to water vapour. So why aren't we all up in arms about the amount of water vapour in the atmosphere? maybe we're right to focus on burning fossil fuels because actually it produces carbon dioxide and water vapour. But why do we focus on the carbon dioxide and not the water vapour? Well, the answer is the amount of water vapour we emit into the atmosphere is tiny compared to the amount that's produced by evaporation from the oceans. You could still say, well, what about this tiny extra bit? Surely that still has some impact. No, the Earth's atmosphere can only hold a limited amount of water vapour anyway, and if we emit further water vapour into the air, it just falls as rain again. There's a fixed amount of water vapour the atmosphere can hold, so we don't actually change the amount of water vapour in the atmosphere, but we do change the amount of carbon dioxide. However, carbon dioxide is not the only greenhouse gas. Now, a bit of maths practice should never be missed, of course, an opportunity to practice that. May especially loves her maths, of course, as does Milia. So here's a little exercise for you. Here's the 4 main greenhouse gases other than water vapour. Their concentration in the atmosphere is shown there, and what's called their multiplier or global warming potential there. What that GWP actually means is a single molecule of methane absorbs 21 times as much heat as a molecule of carbon dioxide, and nitrous oxide 310 times as much heat. If you want to work out the contribution of each of these gases to the greenhouse effect, you need to complete that table. It's on the attachment that I sent you. Can you complete this column by doing exactly what it says there, just the conc times that, and then work out the percentage. You would work out the total of all these numbers and what's the percentage of each of these of the total contribution. Pause the video, have a quick look at that. Answers shown here. So it is indeed carbon dioxide which is the most serious culprit, so we are right to focus on that. Must be said though, that is, as it says there, except water vapour. If you include water vapour, by the way, those are the percentages. As you can see, it's by far the most significant impact. But as I say, its amount isn't changing. Right, just to finish off, you need to complete a couple more bits on the notes sheet. There's this bit here about carbon dioxide levels are increasing due to, obviously, the number 1 is combustion of fossil fuels. Second one is deforestation, although it's not quite as clear cut as some people think. Do put deforestation on the note sheet. Yeah, deforestation is not a good thing. Fully agree. But doesn't mean that I support some of the sort of untruths said about this, all the way sometimes people are slightly economical with the truth. You often hear things said like the Amazon jungle is the lungs of the earth, or the Amazon rainforest actually produces 20% of the earth's oxygen. People are being deliberately economical with the truth there, to be honest. The Amazon jungle is a wonderful habitat and we should do all we can to conserve it, and the way it's being chopped down in Brazil is awful. I fully agree. But the Amazon rainforest does indeed produce 20% of the world's oxygen and uses up 20% of the world's oxygen. It's net zero in terms of its carbon footprint. The same ratio applies to carbon dioxide as oxygen. Mature trees actually are not net absorbers of CO2 or net producers of oxygen. Growing plants are. Mature trees are not. In fact, most of the world's oxygen is produced by algae in the oceans, not the Amazon rainforest. Deforestation does contribute to the greenhouse effect, just because when tall trees are cut down, many of them burned, all the carbon that they'd stored in them, huge amounts of carbon, is then released into the atmosphere, and that does add to global warming. Right, very quickly moving on, just to finish off, I want you to complete that section of the note sheet. and this last bit as well for that diagram of the greenhouse effect. You got one on the PowerPoint there. You can just summarise that. You don't need to copy every word of it, but that would do. Okay, that's it for me for today, but I will get back to you very soon with another video on the nitrogen cycle, which I also want us to cover before the half-term break. Okay, bye for now.